valuable resource for space scientists in coming years. To fly the increasingly sophisticated space instruments of the 70s, instruments which will analyze the discoveries of the 60s, NASA is planning the launch of 3 more interplanetary monitoring platforms, nicknamed IM. From 1963 to 1969, 7 of these satellites have returned enormous quantities of data from vast areas of space. They have flown in a series of eccentric orbits, cigar-shaped rather than circular. These included the so-called anchor IM, which orbits the moon. These spacecraft provided the first accurate measurements of the interplanetary magnetic field, the boundaries of the magnetosphere, and the shock front or bow wave set up by the shield of the magnetosphere against the solar wind. Without this shield, the Earth would be struck full blast. 3 new IMs will seek the answers to the sources of energy in the particles trapped by our magnetosphere. They'll also try to find out what it is that changes their speed. These super IMs of the 70s have 3 times the size and ability of their ancestors. They will carry instruments ranging from Geiger counter telescopes to a small computer, and will study a wide variety of phenomena. Cosmic rays, gamma rays...
Please, let me have my account back, please!
...and magnetic fields, and the solar wind.
What did I even do?
And the astronomer. Their instruments fly side by side, sometimes even in the same spacecraft. The physicist is an indoor man. He works in a very limited laboratory. It is only 1 billion miles wide. The astronomer, on the other hand, works outside that area. He is studying phenomena at distances which range to the very edges of the universe. However, the physicist and the astronomer do have one thing in common: the sun. This incredible furnace converts over 600 million tons of hydrogen into helium every second. Every square yard of its surface emits 70,000 horsepower into space as X-rays, ultraviolet, visible, and infrared rays, and as radio waves. Astronomer, the sun is the only star near enough to be observed in any detail. Since the telescope was invented in 1610, the astronomer's lens has been partially obscured by the Earth's atmosphere. He is continually plagued by the distorting qualities of air, to say nothing of pollution. He is also found that very farther than visible light and radio waves can penetrate it.
for contacting Roblox appeals about your moderation concern.
Just shut up and let me have my account back.
No.
What?
After reviewing all the available evidence, the consequence for this conduct will not be adjusted.
Oh my god.
How are solar cosmic rays generated? How are the charged particles in these rays? And how do they affect Earth's environment? It would be a superstar energy science to advance the understanding of the Earth circling space station will carry even more power.
Okay, it's time to brace yourself. This is not going to be a pleasant experience. Oh god!
Could observe one of your eyes.
Let that be a lesson to never become a Roblox developer, ever. Oh my god.
Technology can be applied to many industrial, medical, and community needs. By contrast with the size of OAO and RAE, a new series of small and more versatile satellites is planned to bridge the gap between sounding rockets and astronomical observatories. This is SAS, the Small Astronomy Satellite. The SAS series concentrate on general surveys of X-rays and gamma rays over a broad area of the sky. The resulting large sky maps are being studied to select areas for closer investigation by other satellites. At the frontier of space science, engineering, and technology for the 70s will be EO, the High Energy Astronomical Observatory. Still being designed, EO will carry 6 tons of instruments to find and measure cosmic rays, their energies, and their velocities. These naturally occurring particles have energies of perhaps 100,000 times those being generated artificially by the largest atomic accelerators on Earth. Somewhere in these phenomena are the secrets of incredible energies, beside which nuclear power is like a small match struck in a dark room. Hio will seek to learn the ways in which these energies are created. Ten years of space science research have solved some mysteries and presented some profound new ones. Mysteries which may be close to explaining man's role in the universe. Within the next 10 years, many of these mysteries, complex as they are, will be well within the grasp of anyone with a curious and restless mind. Imagine a form of matter, which the more you look at it, the less you can see. A star which is collapsing so fast that no light can escape from it, leaving a black hole in the sky. When scientific satellites look across the universe to the quasars, they may be looking billions of years into the past. When they look at a supernova, an exploding sun so bright as to actually cast shadows on Earth, they may be looking billions of years into our future. To a visitor from an equally curious planet, the Earth would have looked no different than this. That day in 1752, when Franklin established the relationship between lightning and electricity. On the cosmic scale, little time at all has elapsed since that event, although our scientific knowledge has exploded at a rate equal to what we imagine the explosive creation of the universe to have been 10 billion years ago. In that so recent tick of time, Benjamin Franklin deposited his findings by hand, by candlelight. Today, by electric light and into an electric ledger, the physicist and the astronomer enter their deposits of knowledge. Little by little, they build a picture of nameless new forces, beside which electricity is an infant. It makes one wonder by what light and into what ledger we will record the future which space science has already placed in our hands.